anything we discuss with logarithmic equations still applies with natural logs too. The only thing that's going to be different is when I eventually convert it into a similar exponential equation or go through the steps I would normally go with any other logarithmic equation. I just have to make sure that base e would be involved when necessary. So for instance, in part A, the natural log of the quantity 2x cubed plus 1 equals 7, the first thing I have to do is turn this into an exponential equation. So, the base is going to be e, so 2x cubed plus 1 is going to equal e to the 7th power. Now, I'm going to leave e to the 7th power as e to the 7th power because e is an irrational number. E to the 7th is going to be yet another irrational number, and if I'm going to try to write it out as a decimal, I am going to be rounding at some point. So, to avoid doing any rounding right now, I'm going to leave it alone. Just remember it is a number. And I'm just going to solve for x. So I'm going to subtract 1 from both sides. I'm going to divide both sides by 2. The thing is, when I leave it as e to the 7th, I lose the ability to put the numbers and get a single number anymore. So I still have to show the operations. I have to make sure I'm showing the operations in the order they need to be done. So in here, I do have to clarify that the minus 1 is being done before the division of 2, and that way I have that fraction bar written shows that. And then I would cube root both sides. And then at that point, if I want to get an answer and round it, I'd be safer, because then if I put that 8.1824 into the original equation, I should get a number that's really, really close to 7. Whereas if I round it at several points during this, it may be far enough away to make you question whether or not that is the answer or not. For part B, I have the natural log of x minus the natural log of x minus 4 equals the natural log of 3. Now, we had an instance in the previous lesson where if I had the same log of the same base on both sides, it would cancel. But that's only if I have a single logarithm on each side. On the left-hand side, I have two logarithmic statements being subtracted. So I have to account for that. I have to get a single logarithmic statement on both sides, and then if that happens, then I could drop out the natural logs. What I'm choosing to do, this is one of a couple options. I'm adding the natural log of x minus 4 to both sides. I prefer using the product property of logarithms than the quotient one because the quotient one, you're running into the difficulty of, creating a rational function, and then you have to worry about the constraints with that as well, and that can sometimes cause issues. So I try to avoid that kind of extra issue that could be represented in it. So I know I'm going to eventually use the product rule for this. The product rule would say, okay, well, the right-hand side is going to become the natural log of 3 times the quantity x minus 4, which when I distribute becomes 3x minus 12. Now I have a single natural log statement on the left, and I have a single natural log statement on the right. Now the natural logs can go away. And then the rest of it becomes pretty much a really simple linear equation to solve. Subtract 3x from both sides, divide both sides by negative 2. I get that x equals 6 as my only answer. When I look at 6, 6 is going to work for either of the two natural logs I have on the left-hand side of the original equation. Therefore, I'm not expecting any kind of domain issues and things like that. So this is, and if I actually put it into the calculator and check it, I do get the same answer. So that is the answer, and it's the only answer. Just because you get one answer, though, because of one that complicated, a logarithmic equation that complicated, has potential for extraneous solutions. Now, even if I only get one solution, that one solution could still be extraneous. So, be on the lookout for that. You should still test it to see its validity. Generally, though, if the answer is not going to create any negatives or zeros, next to a logarithm, or you're going to, by putting it in, you're going to end up taking the logarithm of a zero or a negative, you're generally fine. You usually don't have to go through the entire thing. It's a good idea to carry it out and when you still have the calculator to use and see if it would make sense and see if that would be the right answer. But, you generally don't have to go that far, usually to determine whether or not an answer is extraneous dealing with logarithms. Another equation you might tend to see, now this is an exponential equation with base e. Use a logarithm to help me solve this equation. I need to have a single exponential statement. And I have multiple ones. Okay, so that's a problem. So I got to figure out a way of finding a means to get a single exponential statement so that I can eventually use logarithms to solve it. One of the things I do look at here is here's another instance. I have an equation and I have three terms, three terms of x. Okay, and anytime I see that and I'm kind of stuck this to thinking, well, what can I possibly do? Start thinking like, well, maybe this is quadratic in some way. And if you actually look at a problem like this, if I let a equal e to the x power, then a squared, which would be e to the x power squared, would be e to the 2x. So if I let that substitution occur, I'm going to have a squared minus 4a equals 12, and that is a quadratic equation, and I can use quadratic methods to solve it, whether it be factoring, completing the square, the quadratic formula, whichever is up to you. Here, I said equal to 0 because if I'm going to factor it or if I'm going to use the quadratic formula, I do need it set equal to 0. Although the quadratic formula would work, this thing does factor, and I chose to factor it because I recognized what the factors were. If you don't, use the quadratic formula, you're going to get to the same point. I get that a minus 6 would equal 0 or a plus 2 equals 0 by the zero product property, which means a would equal 6 or a would equal negative 2. Now, you have to remember, I am not solving this equation for a, I'm trying to solve for x, so I do have to substitute back and say that e to the x power equals 6 or e to the x power equals negative 2, and I would natural log both sides. Now, whether I natural log the negative 2 and get that no solution thing because I'm trying to take a logarithm of a negative, or if I recognize e being a positive 2.718 blah 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 number, I cannot take a positive number, raise it to an exponent, and get a negative number as a result. It's impossible. Whether you recognize it there or you recognize it when you try to take the logarithm and you get like a no solution on your calculator, you're going to know that part's impossible. The only answer you have is the natural log 6, which you could just write as natural log 6. That is considered to be a number. It's an exact value.